Hello students, welcome back. So now we are going to talk about one more category of assignments, and that is blocking and non-blocking assignments. So in this video we are going to talk about two more categories, and these are blocking assignments and non-blocking assignments. So let us get started. So blocking assignments, as the name suggests, they are going to block the other assignments. That means first one assignment will be executed, then the next one, and then the next one. We are going to use an equal to operator whenever we are using blocking assignments. The statements that are written in parallel blocks, they will not be prevented by the blocking assignments. So now let us have a look at one such example. I have a module whose name is block. I have declared 5 registers. All of them are 8 bits. Okay. Then I write first parallel block. Between the initial, begin and end, first of all I declare the value of x1. It is 8-bit hexadecimal value 10. That means first 4 bits are 1 0 0 0 1, and next 4 bits all of them are 0. Then I use the $display command. This is optional, but we need it because we want to see that what is going to be exact value of these variables. Next I say x2 is equal to 20. That means first 4 bits will be 2 0 0 1 0, and next 4 bits are 0. And then again I am trying to display the values of x1, x2, x3, and then I allocate x3 to 3 0, and then again I try to display all 3 values x1, x2, x3. When we execute the first one, that means x1 is equal to 10, we are not defining anything for x2 and x3. So only x1 should be updated. Then x2 and then x3. And in parallel to this block, I have one more block where I am allocating the values of y1 and y2. y1 is given 40 and y2 is given 50. All these values we are assigning at t equal to 0. 3 values in block 1 and 2 values in block 2. Let us see what is the output. So as we discussed that everything is assigned at t equal to 0, so we get the output. The first one is x1 is a definite value 10, x2 is undefined, x3 is undefined. Next time x1 and x2 they are defined and x3 is not. And in the next one x1, x2, x3 all are defined. These 3 were blocking statement in one block. So they are executed one after another. Looking at the last 2 results, first of all y1 is allocated, y2 was undefined, and then both y1 and y2. This is happening in parallel. So it will not depend on the complete execution of block 1. So in parallel block 2 is also executed. Now let us put some delays and see what is going to happen. So I have same block, same register names and exactly same allocations, but only difference is x2 is equal to 20 after 20 nanosecond and x3 is equal to 30 after 30 nanosecond. In the second parallel block, I have given a delay of 15 nanosecond for the allocation of y1 and I have given 25 nanosecond for y2. Now let us see what is going to be the output. So here every assignment is performed at different times and they will be printed in the order of their execution. So whichever assignment is printed, that means that was executed first. So here what we see, first of all x1 was allocated as 10, then the next delay was 15, so y1 is 40, y2 is still undefined. Then it was x2, so x1 is 10, x2 is defined as 20, x3 is undefined. Then 40 was for y2, and then we have another 10 nanoseconds and we get all the variables defined. Please remember, these delays gets added and we get the total delay by the time we reach the last assignments. Now let us verify the same using Vivado. So here I have written the same code. I defined one module called block, defined the registers, initial begin, this is my first parallel block, initial begin, this is my second parallel block. Now how do we test it? Using the $display command in Vivado. We had done it on EDA playground, but we have not done it on Vivado till now. So for that, all you have to do is make sure that your simulation source is top module and run the behavioral simulation. That is it. You don't have to go for schematic and all, and you don't need to run the waveforms also. All you have to do is go and check the TCL console, and here you have your output. Everything is printed by using the $display command. The next type of assignments that we have is non-blocking assignments. Here we will use the symbol less than equal to. Please do not confuse this with the relational operator that we use in the expressions or the conditions. In non-blocking assignments, we can schedule the statements without blocking the execution of the incoming or the next assignments or the statements. So here we are not blocking the execution of the next one. All of them will start executing at the same time. That means the processing is being done in parallel. Now let us consider the same example that we have discussed, but this time using the non-blocking assignments. So here we have the same module, same registers and same two parallel blocks. In the first one we are assigning x1, x2, x3. In the second one we are assigning y1 and y2, but we are using less than equal to symbol this time. So what do we expect? All three x1, x2, x3 will be assigned at one time, and y1, y2 also, or what is going to happen? Well, let us see. So the output of our console is this. All the outputs are unknown, everything is x, nothing is assigned, and the reason is because all the assignments took place at 0 nanosecond. You need at least some time for the execution to take place. If you had put the delay in $displays, you could have seen those results, but we did not do that, and that is why no assignments have taken place at that time. After, they have definitely been done, but we are printing it immediately. So students, now we know about the assignments. Let us continue our learning and we'll talk about the conditional statements in our next video. Keep learning. Thank you.